Hello guys, welcome to this video. We are given two strings and we are requested to merge the strings by adding letters in alternating order, starting with word 1. And if a string is longer than the other, append the additional letters onto the end of the string. So the best approach here, I think, will be to use a two-pointer method. Two pointers means we're just initializing two variables starting from 0, and we are going to iterate through the strings or together. We are going to iterate them at the same time concurrently, and then whatever string ends first, we stop at that, and then we proceed to append the rest of the remaining strings to the merge string, they're saying. So in this case, let's say we have A, B, C as word 1, and word 2 we have P, Q, R. So you will be picking A and then P you pick A from the first word, and then P from the second word, and then B from the first word, and then Q, like that. So let's just do this practically so that you can understand what we are saying. I'll just I like to code it locally first before I move it to LeetCode. I can try it in my editor, so I'll just define the same function as this. And then, of course, we are given word 1 and word 2. And our work is just to make sure that we iterate through and return the desired result. So the first thing we are going to do is to initialize a result, an empty variable here, call it result, and then now our 2 pointers. So I'll just call them I and J, and then we assign them 0 each, and then now we are going to iterate through our words. So I think since we are going to iterate through this, we are going to need the length. So I don't want us to keep calculating the length on each iteration. So it would be good if we do len 1, len 2, length of word 1, and then also the length of word 2. So that will give us the two lengths that we need. So we would say if I, as long as I is less than, so our first pointer is less than len 1, and still at the same time, J, our second pointer, is less than len 2, then we are going to append whatever values are at that point in our two words, and then we increment our pointers, and then we move on to the next iteration until one of the words will be exhausted, and then we'll stop at that, and then we will just take the rest of the characters and assign them to at the end, starting of course with word 1. So how we do that is this is how you assign a string. So a string is of course enumerable, so you can be able to do this. So I'll just do J. I'll start with I, so that will be result. So that's word 1 at I, then we concatenate with word 2 at J, and then we increment I plus is equals to J to 1, and then we also increment J. So just make this clean, and then of course now this iteration is going to end when either of these will be greater than the pointer, and then after doing that we'll know now one of the words has stopped, so we cannot continue with the iteration. So that means that now we can get our result as now. What we do is just add the remaining parts of the strings to our result, and then we return that result. So we will take word one, everything from where we stopped, our I stopped, to the end of the string, and then we will concatenate whatever remained in our string 2 from where the pointer stopped to the end, and then we can return our result. Okay, so all right, sorry, forgot I'm doing Python. So this should be fine, and best practice, of course, in Python, we'll do it that way. So let me just test this. Let me first of all run this, and then I just want to test it here. I'll pass in some two strings. Let me just do ABC PQR. So let's just run that, and you can see A, B, C, and then PQR. So it looks like it's working fine. So the only way to find out if our result is working fine is to go back and run it in LeetCode. So I'll just copy my result and run it in LeetCode. Make sure the indentation is in place. And then we can run this and try out. So runtime is that. It looks like our result is accepted. So let's just submit this. And yeah, we can start this study plan. So you can see, wow. So our result beats 94% in runtime and 96% in memory. So it performed very well because our result, our solution runs in O of n. That is the time complexity. The time complexity of this solution is big O of n, which means that the time complexity increases with the number of items in the shortest string. So the space complexity is also big of n, of course, due to the creation of the result. So we created, as you can see, we created a new variable here, and we called it result. So it means that the bigger the string, also the bigger the space that we consume. So our space complexity now adds up to big O of n. So thank you so much. See you in the next solution. So thank you so much. If you are new to this channel, please remember to subscribe. And if you like this video, please like it and share with your audience, with your friends, so that we can be able to grow this channel and be able to impact more developers. Otherwise, thank you so much. Cheers.